like to start out today by showing you a video of a boy who's born with severe combined immune deficiency. And this is the first time he's coming home from the hospital.
I had a big room with my own bed, lots of toys, and 2 pairs of retractable arms.
And the prince climbed to the top of the tower and said, "Come with me, and we'll live happily ever after." Then Rapunzel left her plastic bubble and died. The end.
So, that was from the 2001 film Bubble Boy, and it is a real disease. Severe combined immune deficiency is something that gene therapy has had success in curing. And Human Genome Project Information website tells us that gene therapy is a technique for correcting defective genes responsible for disease development. I've been consulting with some of MCC's finest and doing my own research, and I found that research facilities need more funding to progress gene therapy studies. The results of this research could save millions of lives. The exploration of this medicinal revolution can't continue without the proper funding. An article in the Genetic Engineering and Biotechnology News that I read said, in the early 90s, gene therapy was having lots of success, lots of new developments, but as progress slowed, as research slowed down and they were having some trouble finding new developments, investors stopped giving them money. And the American Society of Gene and Cell Therapy put out a press release that said a lot of the grants that they get for this research last 4 to 5 years, but a lot of that time is taken up by the review process that takes to get something published and get a new technique and a widespread practice like gene therapy. But I'd like to tell you a story about a real-life Bubble Boy. I got this from Easy Mark, an online magazine. His name is David Philip Vedder, and he was born, and 10 seconds after being born, he had to be placed in a germ-free environment, and he had to stay in a germ-free environment for the next 13 years. As he grew older, and he was born before gene therapy was an applicable practice for him. He died in, I think, 1983, and gene therapy wasn't that far along then. But he struggled with social skills, obviously. He was always apart from society, and he eventually lost his sanity, in essence. He became uncontrollable, and after too long, his parents decided to go for a bone marrow transplant that was ill-advised because when bone marrow transplants are a perfect match, they're 20% of the time they're successful. So he had an 80% chance of living with a good match, and this wasn't a good match. And he ended up dying a few days after that procedure. But with the proper support, stories like David Vedder's can have a better ending. I emailed Dr. Obermiller, who some of you may know. He's the head of the biotech department, or the program at MCC. And I asked him a couple questions, and I want to read straight from his email what he said. He gave a really good analogy to describe gene therapy, and I think it can help us all understand it. Gene therapy uses virus vectors to replace genes that are defective. Imagine a paint can you can't get the lid off or is dried up. How do you paint your wall then? You don't need to worry about the old can, you just get a new one. DNA is in everyone, from humans to bacteria, and it is all the same. So your body would never recognize it as foreign, and you don't have to worry about the immune system. The virus is like a delivery driver. It delivers the new gene in the form of DNA, and the new gene is like a new paint can that is fresh. It lets you paint the wall just like the new DNA makes a new protein. And I've been talking with Dr. Baldwin, who's also at MCC's Life Sciences Department, and I got these slides from him. He used them in his Bio 100 lecture, so if they look familiar, that's where they're from. But basically, how it works is you get a virus, and viruses are just these packages, and they come in all different shapes, but they all have DNA in them. And like Dr. Obermiller said, DNA is the same for everybody, every living thing. So we don't need to worry about any sort of matching blood types, anything like that. But basically, you get a virus, and it comes and attacks your cell, and it inserts its DNA into you. And this is a really cool picture taken with a super expensive camera, but these viruses are in the act of putting their DNA in this bacteria cell right here. And so basically, once that is in your cell, your DNA will divide, and it'll make a perfect copy, and so the virus DNA will be copied, and you'll start making the viral protein. And in the case of gene therapy, that's the new, better protein that will help your body function better. This is a karyotype, which this is a normal karyotype. And basically how the Human Genome Project worked is, not to be morbid, but you'd find somebody who was born without eyeballs, and you'd compare them to someone who was, and you would see probably a huge difference. Say, if the eyeball gene is on chromosome 8, they would probably have like the top half lopped off because they don't have any eyeballs. And so then they know, oh, that is where the gene for eyeballs is. And one of the things gene therapy can cure is color blindness. And so if you're colorblind, you can't tell that there is a number in this circle right here. And I'm sorry if this is the first time you're finding out. As these methods improve, even more lives can be positively affected. The nature argument in both psychology and medicine can virtually disappear. The nature versus nurture, nature would disappear with this. Human Genome Project information website tells us there are 4 basic methods of inserting a gene into somebody. First one is a normal gene may be inserted into a non-specific location within the genome to replace a non-functional gene. And it says that's the most common one. And for me, that'd be like, one of my life goals is to grow a beard, so if Alex is willing, I could have his hair growing gene put in a bee, and I could grow a beard. The second way is an abnormal gene could be swapped for a normal gene through homologous recombination. And that would be like, okay, I guess my example is for the next one. The third one is an abnormal gene could be repaired through selective reverse mutation. And that would be like cancer cells. Most people aren't born with cancer, I don't think. So it usually develops somewhere along the line. So to be able to reverse that cancer gene would be amazing. It, in essence, cure cancer, which is a huge goal in the scientific community. And the fourth one is regulation of a particular gene could be altered. And that's like, we're all born with eyes and arms and legs. And so we obviously have the gene to grow those. But some people, in unfortunate instances, lose an arm or a leg or an eye or an ear. So you could turn on the gene that grows that again, and they could regrow it, a full-functioning arm or full-functioning eye. The possibilities for gene therapy are seemingly endless. And that's why I pledge to all of you to not only raise awareness of this revolution in medicine, but to donate to the American Society of Gene and Cell Therapy. Last week I donated $10. And it isn't a lot, and I figure if all of us in here just donate maybe $5, that's still over $100 coming from Mesa Community College, a place where none of us, I assume, even knew about this before this semester, and I think that's a big donation. People will continue to suffer if awareness and funding aren't raised. We must do our part to fund the future of medicine. Are there any questions I can answer? Jesse?
Do you think that it could be abused, like you said, if you wanted facial hair and you decide that you wanted his facial hair gene, that's a little too extreme?
There are arguments against gene therapy, absolutely. He's asking if gene therapy can be abused. And the opponents to it say that you're, in essence, playing God and messing with Mother Nature. And so it's possible to abuse it. And that's why you want to have good standing medical professionals doing the procedures. Does that answer your question?
Yeah, it does, yeah.
Alex?
Would I still be able to grow a beard?
Absolutely. He's wondering if you could still grow a beard. Yeah, because it would just take, a couple of your cells, and then through the Human Genome Project, we know where the hair growing gene is, and we would replicate that one gene like 1 billion times and then put it in me, and hopefully I would grow a beard, but you would still have it in all your hair-growing cells.
You can have it.
Absolutely. Any other questions? Marvin?
So you said that that they could, what was one of the last ones where how someone gets their arm like taken off, I guess. That's not the right term actually, but how they can like give them a gene that give them the capability of growing it back. Is that what he said?
Yeah, absolutely. He's asking if I said that people could regrow arms, and I think that's a definite possibility. They haven't necessarily gotten that far yet, but I think it's for sure possible. Like the website said, the regulation of a particular gene could be altered. You know, we have the gene in us to grow an arm, obviously, but it turns off after we grow arms once. So if we can find a way to turn that gene back on, we can grow a full functioning arm again. Did that answer your question? Yeah. Cassandra?
So it's kind of going off of what he's saying. But we grow our hands and arms and everything while we're in the womb, like our mom, right? So if the idea of growing limbs back or any other part of your body back, would you have to go into sort of like a sleep state or something like that for that to be possible? Or would you just, in theory, be able to just walk around a normal day and just kind of watch it grow?
That's a wonderful question. She's wanting to know if growing a limb is possible outside of the womb. And I like to think it is. We haven't gotten there in the research that I know of, and but when we do get there, I'm excited to find out and to let you know. Does that answer your question? All right. I'm out of time, but thank you guys, and let's help fund the future of medicine.